So hello everybody to next session here. It's an honor to talk to you on behalf of KSB, a global leading company in fluid solutions, specifically for pumps, valves and service. And today's session is about small modular reactors of generation 3 plus and generation 4, and with the subtitle Pushing the Limits of Fluid Solutions. And what is this presentation about? It's about the three guiding questions which are associated with it. It's the why, what, and the how. The why is the global nuclear market of SMR momentum. The what is the technical requirements which come along with the new SMR technology. And the how is how you tackle this why and the what from R&D to prototype to industrialization. My name is Alexander Roth. I'm heading the global sales for nuclear pumps at KSB. And just come back to the guiding questions, the why. I think the why is pretty obvious currently. There's a need of energy like we have never seen it before. We are looking for decarbonization. 10 years ago, we haven't thought about that AI data centers will require their own nuclear power station. So there is a huge demand for decarbonized energy currently. And the what is the new reactor designs and the standards. I think the why and the what, we as a pump supplier and valve supplier and general for everybody who's a component supplier, the why and the what you cannot change. You can somehow tackle it. And the question is how you're doing it. And this is the how. The question is how you get from R&D to prototype to industrialization. To those who haven't heard about KSB up to now, KSB is a global acting company with a headquarter in Germany, Frankenthal, which is close to Frankfurt. We have about 16,000 employees globally, and funny side fact is also we are a German company. Only a quarter of it hired in Germany, and the rest is globally active. We have a sales revenue of about 3 billion euros last year, and earning of 244 million euros, which is a significant increase to the previous year. So let's go back to the why. The market opportunity. And this is, I would say, everybody has to check it by his own. And this is our view, what we currently would like to provide specifically to the SMRs. So we have a real hotspot in North America currently. We see a lot of money which is circulating there. We see in South America actions. In Europe, I would say there's another hotspot currently growing for SMRs and also for Gen 4. And India, we see some prospects there. We see China, which have Gen 3 plus nuclear power stations and 4 already under construction. And we see also South Korea, which is pretty active. And I think the upper line is you see who is really pushing currently, and it's surrounded by other countries globally. So in general, it's not just one let me say, just one point. Globally, where the race is on, it's a global subject currently. And we as a pump supplier and valve supplier, currently, of course, we are focusing of everywhere where main reactor cooler pumps are in. And then you see the large nuclear power station is not the top of today. And we are focused on SMRs according to pressure water reactors, pressure heavy water reactors. And then we see a lot of other really unique technologies like the molten salt reactors or the molten metal reactors. And also, I think it's even it's not, you can judge if it's nuclear or not, but it's fusion, and it's respectively, when we are talking about high temperature applications, molten salt is, or applications and solutions for molten salt is requested by fusion designers, as fusion reactor designers as well. So therefore, don't forget about fusion reactors in addition. So this is our picture, and again, everybody has to judge it by his own if this is valid for the own company as well. And this is our view. And what is the what that comes along with this new nuclear momentum currently? There are new technical requirements. Currently we have, when we are talking about the SMR Gen 3 Plus, we have the large nuclear power stations, we have a scaled down, and but the technical requirements more or less remains identical. So you have operation temperatures at 150 degrees, 150 bar at 300 degrees C. You're using water or heavy water as a coolant. And in general, to come down from the scaled one, from the large one to the scaled one, we are talking about technical evolution which are required to tackle it. But what is the story about Generation 4 right now? Generation 4, it's more or less, I think most of you know this picture already. It was taken in the 60s at the National Laboratory at Oak Ridge. So for Gen 4, you usually start with experimental bases. And the requirements have changed significantly. So you have operation temperatures down to 10 bar, but at significant increased temperature at over 700 degrees C, and you do not use water anymore. You are using sodium or liquid metal like lead or sodium, for instance. And to achieve this, you have to make the jump from the R&D to reach this and to cover all these new requirements, and therefore you need, from our perspective, not an evolution anymore, you need a technical revolution to make it happen. But I think what is more important right now, as I said before, the why and the how. Oh, okay. But what is more important to me is the how. What is the path to industrialization right now? And there are several pillars, I think, which are significant. Usually you are using former projects right now. You are using funding projects maybe. You are doing your own R&D. You're doing test equipment, or maybe you enter into a strategic partnership as well. And then if you go down this path, you have a prototype, maybe at the end, as a solid foundation for to tackle this new generation 4 technologies. For SMR Gen 3 Plus, usually if you are already active in this market, you should be there already. So therefore, again, for somebody who's not active in nuclear right now, of course, this could also be valid for SMR 3 Plus. But it's our perspective. And what have we done in the past so far? You know, Germany already stepped out of nuclear power production right now, but of course we had a significant past and significant historic, and therefore KSB was also very active in that. We provided equipment for former projects like R&D research reactors for the K and K2, later on the large-scale nuclear power station Kalka, which was a sodium-cooled reactor with a design temperature at up to 600 degrees C. What we are doing in addition, because this is the past, what we are doing now, right now, and we would like to close gaps we have, and this that's a fact. I think everybody who is active in that regard right now has some gaps here and there, and looking for how to close them. And we are using funding projects right now, and this is a funding project for molten salt with a pump we have provided, as well as, let me say, a pump for molten salt and nitrate salt with medium lubricated bearings. Also, this test rig was equipped with valves as well. And it passed already a 2,500 hours operation test at the 620 degrees C. And the next one, what we are doing as well, is we have an own R&D test rig at KSB doing molten salt tests. And this one is designed for fluoride salt, and we are doing component tests with that test rig. And in addition, what we are doing else is we are providing test equipment for customers, usually for non-nuclear applications right now, just to create the databases we need. And if you went through this, you have met the technical requirements. You have a prototype, but you have not made it to the industrialization right now. So you have just the technical expertise at that point. And in addition, I just would like to show you our next evolution step here. This is a pump which is equipped with a canned motor, just to simplify the sealing system, get rid of gas lubricated sealing or magnetic couplings, for instance. And you have to build up, maybe if you go this path down, you have to build up know-how in that regard as well. Sometimes you have to judge on your own if it's useful or not, but we decided to enter into a strategic partnership because canned motor design is not our expertise, and therefore I'm really happy to announce that with last week we signed a cooperation agreement with Hermetic Pumps, and therefore we take over the sales activities for selected countries, while Hermetic will provide us with their engineering and know-how for canned motors. And bundled this, you see here our canned motor and this one, and pump with the canned motor, and this one is displayed at our booth here at the KO40 exhibition stand, and you are highly welcome to join us there for a drink and some discussions about it. Okay. We keep in mind, when we have went through this, well, when we went down this path so far, we have met the technical requirements, but we haven't met it to an industrialization right now. And this is, I think, one of the tricky parts, how to make it from a prototype to a digital, to industrialization. And there are some milestones maybe you went through when you make this way. You will talk about early project involvement, hydraulic selections, concept phase. You will talk about quality management, design and engineering, structural mechanics, supply chain, manufacturing, and testing. And when you have went through all this, I think at the end, and you have been successful, you made it to industrialization. And I would like to talk with you a bit about some of these milestones, and let me start just with the hydraulic. I think usually hydraulic is one of the initial phases in a project. So you will get a call, and your customer will require pump equipment with a certain performance, like QNH. So you will provide it. For SMR 3+, I think it's fine. You will rely on what you have so far, and you have established a lot of basic data which can be used. For SMR Gen 4, it's like you have to do an impact assessment, because you have to handle the high temperature. You have to you have to handle the impact which is associated with the high temperature, and also with the new materials which are associated with it. And therefore, for Gen 3 Plus, you're using the existing hydraulics, and you're using you're doing kind of downscaling, because we said we have the same temperature, the same pressure, but usually you have less flow. But that's fine, you can do it. But what about Gen 4? You have to utilize of the existing hydraulic characteristics, and the problem is the influences which come along with it. So, what is your basis for that? Usually as well, it will be water, and you have to judge how you will make the step to some other fluids like molten salt and molten metal. What we have done so far, we have done we try to validate our data models, and therefore we have done a NPSH testing up to, in molten salt, up to 620 degrees C, just to do the validation of our data model, to say if they are valid, or do we have to adapt it. Are the information which are so far available, are they still valid? Are the physical models still valid? Or is there any kind of changes? You have to think about it. And also, what you're usually not doing at that step is you are not considering the impact of the high temperature. Usually, what is the impact of maybe the vane thicknesses? What is the impact of thicker vane thicknesses to the efficiency? And so on. So there are a lot of open questions, and you have to cover them all. Next step to your way to the industrialization maybe is the concept phase. Usually the concepts for SMR Gen 3 Plus are following known layouts, but for for SMR Gen 4, we see a lot of various reactor designs available. And what we have also seen so far is that some of the designs are, let me say, considered by the EPC, so the reactor designer, and some of them only exist like, let me say, like creative concepts. And you have to deal with it. So you have to be influenced as early as possible to provide your expertise as a pump and a valve supplier. And so for Gen 3 Plus, usually specification have a kind of granularity which is sufficient to provide a solution. For Gen 4, it's totally different. So it's very crucial for us to be part of the story, part of the development, part of the reactor development in the very early stage to provide our expertise. And this can also avoid a lot of additional engineering loops on the customer side. And you, during the concept phase, you will also do you will have some very generic discussions about what is the pressure boundary, what are the safety-related function of the pumps, what is about radiation, because Gen 4 they have really high radiation exposures. So how to deal with it, how to provide maybe radiation shielding. Who is responsible for that? So a lot of very basic discussions and basic questions, and you have to discuss them pretty early to have a very efficient development phase. And again, it's also the early involvement of component suppliers will also be very beneficial for the reactor designers in general to avoid engineering loops. So once you think you have a concept phase, there will be a time you will talk about quality management. And quality management is also very essential on your successful way to industrialization. Why is it so important? Because for SMR 3 Plus, you have, let me say, known standards so far. You're using, for instance, ASME Section 3 Div 1, but for Generation 4, there's a swap to diff 5. So you need new certifications in hand. You have to be qualified. And this, at the end, is, let me say, the latest point where you have the influence from the engineering to your whole organization. And you have to be aware of it. You have to include your whole organization to be successful in the certification process. So for SMR 3+, usually, if you're active in nuclear, you should have the required certificates in hand. For generation 4, you have to demonstrate it. We had to demonstrate it early this year. We passed the ASME Section 3 Div 5 survey at elevated temperature service, and this has also an impact on your structural mechanic team, because you have to provide evidence for the new calculations like creep and fatigue analysis. So there's a lot of additional iterations which comes along with it. It's not just you doing your survey and you are fine. So this time you have to do some extra work and some extra homework. And also, what is very important is currently, if you're doing some kind of fatigue and creep analysis, you will come to a point where you will not find sufficient databases in your code, and then how to handle it. So you have to close this gap, and usually nobody will help you, so you have to do it by your own for the moment. And this means what we are doing is we are working closely, very closely together with institutes to create all this missing material data to do the analysis at the end. And then, just said, structural mechanics is already required for your Div 5 and STEM certificates. And usually for nuclear applications, you have a lot of very complex requirements regarding your calculations and analysis. And this time, it's also the question is how to handle it for a new subject like Gen 4. And while you do it for 3+, like you have your certified calculation models in hand already. You are using them, it's just a smaller pump. But you do not have to develop anything new right now. You have to adapt it. But the load cases as input data, these are mainly standardized specifically for the pressure water reactors. And so you're using what you have already. For Gen 4, you have to do the demonstration. You need new approaches, you need new computational analysis models which have to be validated. And this is something which is not so easy to handle, and it needs a lot of effort, and usually you need external expertise to support you, to bring you for Gen 4 on a level like you have it already for this subject for Gen 3+. And then, if you went through all this, you have your concept design, you have done your homework regarding the QA, you have done your homework regarding structural mechanics, you come to a point where we have to talk about manufacturing and the supply chain. I've just seen their own workshops only dedicated to the supply chain because it's so tricky topic right now. And you know, for SMRs, it's a small modular reactors, so this means we are expecting a really high quantity. Currently, we do not have this high quantity. So we have a demand of maybe special materials in a very low quantity. Later on, you will have a really high quantity in very specific materials. So the whole supply chain have to be built up. And it's not something which can be solved purely by the component supplier. it's up to the supply chain in general. So the material suppliers have to be involved and have to provide their willingness to support this. They have to believe in the same as you. So if you believe in the market and if you believe in this business case, your supply chain has to do the same for you. So also a topic will be, usually you're just talking about forging materials or casting materials, but what is also about the trade items. Supplier for trade items, I think they will have to do their homework as well to be part of it, and it will be a really major step to do also for them. At the end, for the manufacturing, main influence will be when you are, currently we are doing kind of engineering, means we have low quantity per year, but for SMRs, you have to scale it up. You have to scale up your production. Maybe you have to do a kind of investment. Maybe you have to rethink how you're working. You have to establish a serious production and lean production compared to a engineered production as before. And for Gen 4, it's also about new materials, how to handle them, how to source them. Maybe for sourcing, also additive manufacturing could be of interest. So KSB is already active in additive manufacturing over 20 years right now and trying to build up all this expertise. So for Gen 4 and specifically for test equipment, we are printing already our own impellers or pump casings, using them for test purposes, and also have our lesson learned in that regard. And also for SMRs Gen 4, you have to change your production to a series and lean production. And for sourcing, maybe you have to rethink your sourcing model, and maybe you have to start and enter into sourcing alliances. You do not know. And in general, what we have also seen so far, concepts for Gen 4 reactors, which has a really huge dimension, means length of over 14 meters for the pump. So how to handle pump equipment which is 14, 15 meter long? Does it fit in your factory? Maybe you have to reinvest your whole factory. You have to rethink everything. And then when it comes, when you have manufactured your pump, it comes to testing. Usually the pumps are undergoing a really comprehensive testing program, also for Gen 3 Plus, of course, but you're mainly using your existing test loop. So here's a picture of our RCP test loop in Shanghai at our joint venture SEC KSB, and this one is also capable for main reactor coolant pumps for Gen 3 Plus. But for Gen 4, you have to think about how to do the testing, because there's so many different mediums out there, like chloride salt, fluoride salt, with or without fuel in it. You have sodium, you have lead, and so on, and you have different compositions of it. You as a component supplier, most likely you are not able to handle all of them. Maybe one or two, but not all of them. How to deal with it? And I think what you can maybe do is you can think about doing a kind of component tests to verify your components of your pump, maybe like bearing verification tests. But how to handle the testing, and also how to handle testing for really huge pumps which have a length, as I mentioned, over 14 meters. And it's the same for the testing as for the manufacturing sourcing. I think here is a point where we think challenges prevail the solutions. And I think I have shown that we have some solutions already in hand for some of the topics, but not for all of them. So this means we are still doing our R&D work in that regard and pushing us as well to meet it. And at the end, when you went through this path, you made it to the industrialization. And as I mentioned before, the R&D and the prototype, this is your solid foundation for your success. And the way down from prototype to industrialization for large nuclear power plants is pretty similar to the Gen 3+. So we have seen that there are some challenges associated with the Gen 3+, but it's pretty similar to what you have already in hand. And then we have the Gen 4. And we have seen it, that there are significant changes, and you have to deal with all of them. You have to tackle them, you have to provide solutions for it. And what is also very important to know is that between 3+ and 4, it's a different working method. It's a different working method in your whole organization. And you have to take your whole organization with you to be successful. And at the end, when you go a step back, this is how you are pushing the limits. And believe me, what is one of the key and the success factors will be the mindset. Without the right mindset, you will not make it through the whole path down to the industrialization. That's it for the moment. Thank you very much. And now it's time for questions and answers, if you like.
Thank you for the presentation. I have a question regarding the environmental condition in case of severe accident. Do you have any idea what will be the difference inside the reactor building, pressure, irradiation, dose absorbed, and temperature?
So for us, it's pretty simple. Why is it pretty simple? Because we have to keep everything inside. So we have to provide a pressure boundary which is capable for the whole upset conditions as well. So this means is, I think one of the examples which is pretty simple to see is our strategic partnership with Hermetic. So we just try to provide exactly this, that we have a free of failure pump, and therefore we are equipped with a canned motor to avoid sealings, to avoid magnetic coupling, to avoid equipment which could fail. And so this is our, let me say, our doing to cover what you're looking for, because you're absolutely right. Everything which is inside the loop and the reactor should remain inside, and it's our task to keep it inside, specifically for our component. Any further questions? Oh, it's already finished? Oh. Just see I run out of time, so thank you very much. And again, you're very welcome at booth KO40.